Hello. This is a demo I told you I would make for CS2 May term 2023. It's going to illustrate several of the things that we've just looked at in class and a couple of things that we might not have looked at yet. I went ahead and got the basic program here. I apparently haven't saved it, but it's just all the stuff that you have to have in every program. What I need to do, let me see. I want to keep up with food. New data type. Maybe I'm going to start trying to watch what I eat a little more closely. Data type, all one word. So I'm going to keep up with food, and structure is how we put a bunch of stuff together into a new data type. And I'll call it food with a capital F. Notice adherence to conventions. New data type starts with a capital letter and it's camel cased. What else we got? You know what? Let's just do strictly fast food. Then it's clearly camel cased, isn't it? So let's just do fast food. And the fields, I need a string just for the name of the menu item. And of course, our enemy, the int for calories, CALORIES. And that'll be enough. I mean, those are grouped together. And as you'll remember from class, everything in a structure typically has to do with one item. So the name will pair with the calories. If I say milkshake and 1,000 calories, then those two things go together, don't they? Like bread and butter. Now that I've got the new data type, I want to do stuff with it. I want to read a list of fast foods. Now, I will incrementally put comments in the header that explain what's going on. So this is a demo of several different things. Colon, colon, no, colon. It's a demo of how I can't type. There's one thing. Another thing, top down. Top-down development, and I'll have other stuff, so I'll go ahead and put the closing comment. But top-down development means you start with a big idea from 30,000 feet, and you gradually work your way down to the gory details when you can't break it down any further. This is a function writer's dream. It's a procrastinator's excellent dream because it means you don't have to do everything little before you do the big stuff. Here's what I mean. Here's exactly what I mean. Read a list of fast foods. Okay, read fast foods. How about that? I'm calling a function that doesn't exist, but I'll have to tell it what to read it into, and I'm going to read it into an array called fast food. Each fast food element in the array will be one of my food structures. So I've called a function that doesn't exist, but I better only pass in variables that exist. So if I'm going to do that, I need a fast food array. I could call it FF, but I've already called it fast food right here. So I know that's the biggest cursor you've ever seen. Fast food. And I need to say how many I can have. Fast food. You know what? I'm going to make that all one word just to browbeat you into making my point here while I'm coming up here and inserting a symbolic constant, SYMBOLIC, CONST. No, I can't type and talk at the same time. STANT, const, or it wouldn't be a constant, int, fast food. And we'll say maybe we want to keep track with up to 100 menu items. What is the point that I'm making, or do I have one? Look at this. Fast food, fast food, fast food. Those are three different identifiers. How do I know what is what? Fast food, all in capital letters, is a symbolic constant. Fast food, camel case, starting with a lowercase letter, is a variable. Fast food, camel case, starting with an uppercase letter, is a brand new data type, a structure for fast food. Conventions are your friend. Look how conventions allowed us to use practically the same word all the way across. Okay, enough about that. So after I read them, it'd be great to print them out, wouldn't it? Print out the list of fast foods. And there you have it. Print fast foods. Now, I mentioned in class, we haven't looked at enough examples yet to understand exactly why this might be. But not only am I going to have to pass in the array of fast foods, I need to tell it how many are in there? How many have been filled in? Because you know what? Even though I've got an infinite amount of time on this demo, or at least until I run out of computer memory, I am not going to type in 100 different fast foods. In other words, I'm not going to fill in the entire array. I need to tell this function that's got to print them out how many were filled in. So I'll just call that fast food count. Once again, leaning heavily into top-down development. I go ahead and use variables that I know I need, but I haven't even defined them yet. Okay, I'll go ahead and do that. Int fast food count, and it's a counter. I'll initialize it to 0. Let's see here. So far, I've got to read a bunch of fast foods and turn around and print them out, and done and done. That's all there is to it. Except the problem is that these functions don't exist yet. There's going to be a couple of steps I'll need to make, but let's just for fun, let's see what the compiler thinks of this. I don't think it's going to be very happy with it. I can't read that tiny print. It says what? Read fast foods, not declared in the scope, whatever. Okay, it doesn't know that function. Here's some things we're going to go over in class, so watch out for these. We'll have to have every function we want to use in our program, we'll have to have a prototype. P-R-O-T-O-T-Y-P-E. Function prototype is an exact copy of the first line of the function. And read fast foods, at the moment it doesn't look like it's returning anything, so that'll be void. It doesn't return anything. Read fast foods. And I'm passing in an array. Now, when I actually pass it in from within the main program, all I put is the variable name. And the compiler figures out, well, you know what? Fast food is an array of fast food structures. But I've got to specify that up here in the prototype. So this is using my brand new data type, fast food. Notice that I can't do the prototypes until I already have these things done, because it's not going to know what a fast food is if I try to do the prototypes before the structure. And what is it? Fast food, I'll call it FF for short. FF will be its parameter name in the function. And I have to put empty square brackets to indicate that this is not a single fast food structure. This is an array of fast food structures. And I also got to print out how many of them are filled in. I'll call that FF count. What have we got here? We've got a prototype that says, I want to be able to read. Whoops, wait, no, we're not. We're not passing in count. We don't know how many there are going to be. That's up to the user. Silly me. I should look at this. This is passing in a single parameter that's a fast food array. And there we go. FF with square brackets means that's a fast food array. It's the other one that needs a count. The other one, print fast foods. Also void, print fast foods. And this one wants two things passed in from the main program. It needs that array, of course, of fast food structures, fast food, FF, I'll call it again. I could reuse fast food variable name, but I think that would be confusing because FF is going to be the name I use for this array down in the function. Fast food is the name I use for the array in the main program. So there's the array, and I also need to pass in this separate thing, which is an integer variable, and that is int FF count. It says how many things have been filled in. Now let's see if the main program likes that any better. Not the main program, the compiler. Main program doesn't like or dislike anything. I'm going to hit the gear because I know it's not going to run. What's it saying now? I can't. I just have to assume what these errors are. That's too tiny for me. Undefined reference to read fast foods. Read fast foods. Read fast foods. We've got all of it. Oh, but we can't call the function because the function doesn't exist. So let's make a function. I'm going to make a bunch of functions. So I'm going to put a bunch of comments here. F-U-N-C-T-I-O-N-S. Spelled it right the first time. And one of the functions I need, you know what? The functions I need so far are up here in the prototypes. Control C does the copy. And down below here, Control V pastes it. And so that the function exists, I can just put empty curly brackets. That's what's called a stub function. Another handy tool in top-down development. Now, this is actually a real live function. So is this one. They just don't do a darn thing. But they do exist. So I can call them. They're just not going to do anything. Now I can fill them in my leisure time when I figure out how to read fast foods and how to print fast foods. So we'll do that. Let me see if this will compile. Save. Try to compile. I can't tell what that says. Build file, no, 0 error, 0 warnings, yada, yada, yada. So I can actually run it, compile and run. Well, wasn't that fun? It didn't do anything at all. But look at the setup that I've got here. I've already got my brand new data type. I've got the symbolic constant for the array. I've got the prototypes. I've got the functions. The functions just don't do anything. So now I need to get busy and actually put something in these functions. It's going to make sense to do read fast foods first. I can normally do them in any order, but I can't print any out unless I've read some. So look at me documenting my functions. Function read fast foods. What is this function going to do? You guessed it. Read a list of fast foods. Rita, lovely Rita, meter maid. Read a list of fast foods. Ugh, that's hard. How am I going to read? I've got to ask for name, calories, keep up with how many there are. Oh my, that's so confusing. Let's do this. I'm going to read them in one at a time. I'm going to start by passing the buck. You get to do that in top-down development. I'm going to call another function, read fast food, with no S, so it's only going to read one. And I only want to read one of the fast foods at a time. FF square bracket I. That'll read the ith element of the array. Except I doesn't make any sense here. I'm not in a loop, and I don't know how many there are. It's reading a list of unknown length. So I'll have to read one and then keep going. Let's see here. Instead of calling this I, then I'll call it what it really is, FF count. It's a fast food count. And since it's a counter, let's initialize that to 0. Int FF count equals 0. Now it will read 0 the first time. Read fast food. I'll need to set up a sentinel. Let's say there's not a fast food named XXX. Const string FF underline sent for sentinel equals XXX. So that'll let the user know that they can type in XXX and stop typing in fast foods, for crying out loud. So here we go. Down here, read fast foods. And if it's successful, let's say that read fast food is going to return true. If yes, it did read a fast food, and false if it read the sentinel value instead, and there's no fast food to read. So I'm going to test the return value. If read fast food equals true, then what am I going to do? I'm going to bump up my counter. Well, you know how to do that. Plus FF count. Everything's doubled. Plus FF count. Now, what have we got so far? I don't know why there's a semicolon there. Did I put that there? What have we got? Read fast food count equals true. Plus FF count. Well, now that kind of little sort of makes sense, I think. If, and only if, what I don't have, if I had a function that would read a fast food when I tell it which fast food to read, except I don't have that function yet. Mental note, it needs to return a Boolean value. If the return value is true, that means it read one, and we increment the counter. But look at that. That's one and done. I might want to do this several times. Watch this. Instead of an if, while. While I keep calling this function, and it keeps saying true, that means it read another one. So if I call it the first time, it's passing in FF count 0. I'm just going to call it plain old count. I've got too many FFs floating around. Plain old count. Don't trout. Plain old count. So if I'm successfully reading in plain old count, it doesn't like count. It looks like that's a reserved word, so I better be careful with that. Just single F count. I'll get it eventually. Single F count. there. Single F count and plus plus single F count. Here's the logic. I set my counter to 0 because I don't know how many fast foods I'm going to read. It depends on how many the user wants to type in. Then it's initially 0. If I read in a fast food into structure number 0 in the array and it returns true, then I bump it up and FF will be 1. If that's all the user wants to type in, then they'll type in the Sentinel next. And this won't be true anymore because when I call the function and it returns false, it will kick me out of the while loop and F count will tell me exactly how many they typed in. So it's going to keep reading an increment and counter, reading increment and counter until the user doesn't want to type anymore, and then it'll return false. I act like this is all a done deal, and it is not. It is not yet written. Read fast, that Freudian slip there. Food, read a a single fast food structure. Read a single fast, well, it is a structure. I'll just call it fast food. Read a single fast food. Now what I've done here is pass the buck so that this function does almost nothing. It passes off all the work to another one, and if this one can get away with it, it might do the same thing. Now this one can't return void. This one's got to have a return Boolean value, true or false. Bool, because it's got to say whether or not it actually was successful in reading a fast food. Fast food, and it wants to read in. Now notice we are not passing in the entire array. This function doesn't know it's reading in an array element. All it knows is got to read in a fast food structure. And I'll just call that F food for fast food. Now, here's what we got to do. When we're getting used to passing parameters in C++, if this function needs to be able to change the value, which in this case it does, then we have to pass it in by reference. That means we've got to have an ampersand there. Oh my goodness, I will go into excruciating detail on what that means on Friday. Tomorrow, May the 5th be with you. But just for now, just mental note, if I want to pass in a fast food structure named ffood and I want to be able to change its value and make it stick, then I have to put that ampersand after it. That's an indicator that I am going to try to change the value. So here we go. Let's, now we can't put it off any further. We got to read this stuff. See out. And, well, there's not too much to read. I need the name and the calories. Okay. Fast food name, colon space. There's my prompt. CN, and I'm reading into F food dot name. You might wonder, where are the square brackets? This function is well aware that it's looping through, using a while loop, looping through an array of fast food structures. This function has no such indicator and no idea that this F food thing that somebody passed in, which is a single array element, it does not know that that is an array element. All it knows is it is a fast food structure, so it just reads directly into the name. And let's test for the Sentinel before we forget. If F food dot name is equal to, did I have a Sentinel already? I did, FF sent. FF underline sent for fast food Sentinel, all caps. If that's the case, then let's get the heck out of Dodge, return false. Don't try to read any calories if it's if the user is done entering food names. If they are still here, now you might think, we better put an else, but think about this. If it's a function and it's returned, then we're gone. We went back to where we came from. We're not still here. If we are still here, that means the fast food name is not equal to the Sentinel, in which case we need to also read the calories. Well, I'll call it that same thing. Fast food. We've got a lot of motorcycles around here. CALORIES, colon space, semicolon, and read them into the, whoops, not that way. Read them into the F food dot calories. Now, we were successful. The Boolean value here is a promise that read fast food is going to return false if it fails. If it's unsuccessful, it did not read a fast food. It will return true if it is successful. It returns true if the user types anything other, not true, but true. Returns anything, types anything other than the fast food sentinel, and we take that as a legitimate fast food name, and we also read calories to go along with it. Okay, so this one is calling read fast food in a loop, yada, 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 and it keeps incrementing count. Let's say that the user types 5 fast foods. If they type in 5 fast foods, then the main program is going to need to know that. It needs to know that fast food count is now 5. And if you look through this tiny little 2-line main program, there is no way right now for this function to know what the fast food count should be. So here's what we got to do. Read fast foods is keeping up with how many the user types in. So we can say fast, if we can spell it instead of fat. I tell you what, that's got to be a Freudian slip. Fast food count equals, which means now I've got to change everything about read fast foods, or not everything, but some things. Read fast foods is no longer going to be a void function. It's going to return a number. It's going to return the number of foods that the user types in before they type in the sentinel. If we start off fast count at 0, it gets incremented every time. The read fast food returns true. And all we got to do when we read them all is return, not true, not void, return the number of fast foods that were read in so that the main program can also know how many were typed in. Return F count. Okay, so what we have so far, like the first half of the main program here, if all it's doing is going to read and print fast foods, it calls a function to read all the fast foods into the fast food array of fast food structures. And it's storing the return value, which this function is promising to tell us how many fast foods were read in, so that now print fast foods will be able to turn around and print all of the ones that were actually filled into the array. It's not going to try to print all 100 or whatever that was. It's going to only print out the ones that were read in. Now, I don't know that this will compile and run, but even if it does, all it's doing so far is prompting for things. It's not really reporting anything back. So rather than going ahead and through all of that, let me do this part. Let me say cout in an inline to make it look pretty. And we'll just tell the user what they've done so far. I'll get rid of this later, but this is a debugging tool. You type TYPED, it's many fast foods, FASTFOOD COUNT. I do that all the time. Fast foods. And the print function, it exists so that we can compile and link and run and test incrementally, but print fast foods doesn't do a darn thing yet. It's still completely empty, also known as a stub function. It is a function, it's just a completely empty function to be filled in later. Let me see how badly I broke this. I'll save it and optimistically click on the gear and the triangle to compile and run, and it does not. You typed, how about a semicolon? Yeah, that'd be a good idea. And save and compile and run. Oh, what now? Read fast food was not declared in this scope. Read fast food, read fast food. Read fast foods. Oh, I've got a prototype for the plural, but not for the single. Oh, darn it. Well, look what I can do. Look what I can do. Look what I can do. All I got to do is go to the beginning of that line, shift down arrow, and control C to copy, and then zip back up here to the prototypes. Since it'll complain, it's got to see the prototype. Control V. Whoops, I didn't hit enter first. I'll hit enter second. There. And replace the open curly bracket with a semicolon. Bada boom, bada bing, as if by magic. I now also have a function prototype for read fast food. This tells the compiler, don't get bent out of shape. There is going to be a function down at the bottom called read fast food. And it's going to take a reference parameter of type fast food. It's going to take a reference to fast food, and the variable name there is ffood. And it's going to return Boolean to say whether or not it was successful. Let's try that. Compile and run. we're in business. Fast food name, burger, of course. Calories 200. I don't know why I'm bothering to type all this in. Pizza, 200, optimistically. No, 250. And now I'm done. You know what? Mental note. I didn't say how to stop this crazy thing. I've got to type in XXX. You typed in 2 fast foods. That's true. That is exactly true. Let me make a quick adjustment here. Fast food name, space, open square bracket. This is going to look ugly, but it'll be pretty on the screen. And then I'll type FF Sent, SENT. I'm telling them how to quit. FF, and then another string, to quit. QIT, close curly, not close square bracket. Now, what this will do is prompt for the fast food name, and it'll tell them print our Sentinel. Now, remember, there might be a special black burger at McDonald's that's called XXX or something. So we've got a symbolic constant here, and we can change the Sentinel just by changing that one line at the top. And we might be using this in several places, so it's better to have a symbolic constant. So it'll build in our fast food Sentinel into the prompt. Or so I talk as if all this, well, of course that's what'll happen. It might not even run. Oh, look, it does it correctly now. Let me make it bigger so I can see it. Fast food name, XXX to quit. Egg. A boiled egg, that could be fast food. 100. Bacon. Bacon. 500. Lots of bacon. Oats. That's not fast food. That's breakfast food. Oats, those are good for you. 200. I'm tired of typing. XXX. And it looks like our count is correct. So read fast foods. I don't know whether it's reading all this stuff into structures or not, because there's no way to print it out yet. But we do know this is what we might call a parity check. We do know there's at least one thing right about it. At least it's getting the count right. So maybe it's getting the rest of it right. To be able to figure that out, we will have to implement this stub function down here and go the other direction and print everything out. But you know what? For now, so this video ain't incredibly long, I'm going to close up shop and do a second piece of this video demo. For now, I'll see you soon.